Yeah, any one of you? Okay. So so I hope at least you should tell me whether you know or not whenever I ask. So at least I will be able to get to know whether you are following me or not. So it's a request that you should answer me whenever I speak out your name or whenever I ask you something, right? So for now, let me just tell you. Yeah, so biological hazard. So you know COVID-19. So you know how much dangerous it was, and through air it was transferring from one person to another person, and you know how much damage or how much deaths it has caused. So it is nothing but a hazard in the form of biological agent which has caused. Now there could be some chemicals as well, okay, because there are growing number of industries nowadays, and that is why chemicals like, as I mentioned, especially non-biodegradable ones, they have the tendency to accumulate and later they cause hazardous impacts to living organisms. So now the amount of risk, how much risk you have, it depends on what hazard it is and for how much time you are exposed. Let me give you an example of COVID-19. Okay, so it was airborne microorganism which used to spread through uh, uh, okay, it can spread to water. It can spread to someone who is infected if he or she sneezes. Then by that, okay. So for example, that COVID-19 is present in many people. So more the number of people you interact which has COVID-19 infection, more are the chances or more is the probability that you will also get infected. So similarly, uh, exposure. Okay, so more the exposure, more is the risk or probability of has adverse impact, right? And obviously, what agent through what agent also hazard, like for example, in instead of COVID-19, okay, so COVID-19 has caused deaths also. Now, instead of COVID-19, there is a bacteria which causes typhoid. Okay, and you are consuming water which has bacteria that can cause typhoid. So here the risk is what, it can cause fever, but it will not end up into like such severity that it will cause death. So such analysis, like what amount of what levels of risk it can cause, such analysis needs to be done. Okay, so which is more toxic or which is more dangerous, we need to find out. So some of the danger hazards which can be identified in humans, these are the examples. So human can have carcinogenicity. So carcinogenicity is nothing but related to cancer causing things. So anything that causes cancer, they are known as carcinogenic compounds. So carcinogenic compounds, example of those are uh, consuming water which has heavy metals, which has arsenic. Okay. Now further consuming, if you are more exposed, your skin is more exposed to UV radiation. Okay, so UV radiation is also carcinogenic. Now, more and more UV radiation you are taking, it gives you more chances of cancer. Cancer. So that is why. Nowadays, during summer, you see more UV radiations are coming because ozone layer is depleting, and okay, so UV rays it can cause cancer. So that is why we are advised to have a proper care from that sunlight. Then cardio is related to heart. Then neuro is related to neurology, and there could be some damage to DNA also. Okay, and there could be some damage uh, to other body organs as well. Now, environmental hazard could be aquatic toxicity, where water is toxic. There could be phytotoxicity, which is for the plants, right? Now, other example of hazard is nothing but physical hazard, where, for example, explosion occurs in an industry. So, now due to that explosion, there are various gases gaseous which are emitted into the atmosphere. Further, there could be some injuries or burns to the human beings that are working, or there could be some death also. So that are the hazards due to explosion, right? So these are the examples of physical hazard, and some of the global hazards that are nowadays common are global warming, right? So average temperature has rise so much such that it is getting very difficult, sorry, for us to live. Okay, so we cannot imagine going out in summers. So such adverse impact due to global warming has caused. Now, acid rain. Can you tell me what is acid rain and why it is caused? Yes, Sudeep, can you tell me?
Because of pollution.
Sorry.
Because of pollution.
Yeah, so can you name some of the gases or like what type of pollution can cause acid rain?
That I don't know. Carbon dioxide.
Yeah, so there are gases, okay, which are acidic in nature. For example, there are gases which are emitted in the form of carbon dioxide or carbon monoxide, NOx, SOx, right? These are the gases which are emitted in the atmosphere or which are commonly present in the atmosphere. Now, this could be due to vehicle emission, right? Or this could be due to industrial emission. Now, due to the presence of these gases, the water which is or water vapor which is present, it tries to react. Okay, so these all are known as acidic gases because if water reacts with carbon dioxide, it forms uh, carbonic acid, right? H2CO3. So such uh, mild or weak acids, if they are present in water and if rain occurs, then that water has this inbuilt uh, carbonic acid along with pure water. So, due to human intervention, more and more these gases are present, and due to that, uh, more and more carbonic acid, some sort of sulfuric acid or acid, nitrous or nitric acid due to NOx, they are coming along with the acid or the rain which is falling. So the pH of that water which is falling as a form of rain, it reduces and it is known as acid rain. And there are cases where due to excessive heat there could be more rain also which can cause flooding, or even there are places where water scarcity or no rain, like sometimes it can happen. So such adverse impacts nowadays are very common, right? So we need to have a look into what are the reasons behind it, first and foremost thing, and later what could be the adverse impacts, and what are the measures we can take to reduce those impacts. So here, this analysis is nothing but known as risk analysis, where first we try to find out the hazard. So, hazard identification, it involves the trying to find out what are the sources of hazard and what could be the potential adverse impact it can cause. Okay, so first and foremost thing is to find out what is its origin and what could be the disease, or it can how much hazardous it is and to what population it is. So now next step is, once you have find out that say for example COVID-19 virus is the source and it is causing harmful or even deaths to human being. So once you have find out, you analyze how much deaths are occurring. So you assess the risk. You find out what is the number or how much uh, deaths are occurring. So that sort of assessment or analysis has to be done. And later, the management teams, they find out the solution. Okay, so for COVID-19, say for example, the solution was you need to take steam so that virus which was not able to sustain at higher temperatures, it gets killed. Okay, so the risk management teams, they find out the solution or maybe some drugs, and later it is communicated to all the uh, people who are involved, and so that lesser hazard can be obtained. Now, this hazard, you can say, the amount of hazard, as I mentioned, it depends on, or the risk, it depends on hazard and exposure. And here, the exposure, you can say, for example, if a person gets uh, come into contact with COVID-19 infected people, so more the number of people it comes into contact, more will be the chances. Okay, so exposure here depends on intensity, frequency, how much, like how frequently you have contacted, and also the duration. So, for example, if a few seconds and few days, they both are having different impact on the adverse impact that can happen, right? So here one term that needs to be understood for exposure or to quantify the exposure is the intake rate, right? At what take rate you are having the intake of the, say for example, water which is polluted. If you are inhaling air which is contaminated, which is with COVID-19 or some carbon dioxide, excessive carbon dioxide, or some SOx and NOx, then it will cause obviously the adverse impact. So at what rate you are taking that uh, polluted stream, it can be water, it can be air, right? So at what rate it is the measure of the exposure. So that is nothing but dependent on concentration of the pollutant in the atmosphere. For example, you are consuming water with arsenic. So more the concentration, more are chances that it can cause adverse impact. Then say for example you are consuming water. So usually human being takes 2 liters of water in a day, but you are so that 2 liters of water it will add up every day. So how much you are drinking or how much you are inhaling in the case of air. Now frequency. So frequency is nothing but how much, for example, if you have been to a place where the water was contaminated with arsenic. So you stayed there for a day and you had that water only for a day. Otherwise you are not taking that water. So that frequency also matters. So for drinking for a day could not pose much toxicity as compared to the one which where you are drinking every day, right? So exposure frequency and duration, how long you are taking, it also depends. Again, it depends on average time for which you are exposed and the body mass. So the intake rate is defined as uh, the concentration per unit body weight per unit time, right? So more the amount you are having of the pollutant, more are the chances that you can have adverse impact. Now to find out that what, for example, water is having arsenic, right? So you can have literature, or you, if you Google it, then there are in the CPCB website, you can have a list of what water is good for drinking. So there are uh, uh, standards. For example, arsenic should be less than zero point zero 0.01 ppm in water. If you drink more than that, it can cause adverse impact. So for that, how have you find out this values? Okay. So for that, what we do, we have animal studies and we have dose response and toxicity assessment studies. So for that, what we do, animal studies, and in that, animals which has a tendency to behave similar to human beings, they are fed with similar contaminated or polluted, maybe water or air, anything, and later we find out what at what concentration uh, adverse impact is observed. Okay, so there are different terminologies. So that is, first, there's no observable adverse impact level. Okay, so that is nothing but, so let me show you the graph. So let's say from this point, the adverse impact starts growing. So this is the concent- concentration and this is the adverse impact, right? So after certain concentration, uh, there are chances that adverse impact starts appearing, and here it could be some deaths as the uh, uh, way of identifying adverse impact. So maybe here you can see fever. So such concentration is this concentration where there was no impact at all. Now, after certain point, there is a sharp rise, and that is nothing but threshold limit. So, above this point, you should not at all consume. And such curve is nothing but known as dose response curve, right? And there is a factor known as hazard quotient. So that gives you the idea. So hazard quotient or index, it should be less than 1. So more than 1 means that it is hazardous and it will cause adverse impacts to human or any other living organism. So this is the intake rate at which you have taken that pollutant, and this is the reference dose, which is nothing but this concentration where no impact was observed per unit uncertainty factor. So that is a factor which is well defined and you can get it from literature, and that is a factor that needs to be divided. Now this graph that I had shown was for non-carcinogens, which is non-cancer causing adverse impacts. Now, in case of cancer causing impact adverse impacts, this there is a linear graph. Okay, so this dose response curve is a linear graph, and this slope is known as slope factor that you might need to have hazard quotient to be calculated. Okay, so this is all about the lectures that were taught during the last week. Do you have any doubt or anything? Okay, so if not, let's move to the assignment part. So first, this is week zero assignment or just a basic assignment, which is general sort of. So here you only have to answer me first. After that only I will answer the questions. Okay. So the first question here is the contaminated water can be purified by removing which of the following? Okay.
All the above.
Yeah. So here all the above is the correct answer because all these which are mentioned are the contaminants. Okay. So uh, these contaminants needs to be removed, and after that, if you have purified, then you can consume. Okay, so biological contaminants, it could be because of bacteria, fungus, virus that can have damage to intestine, lungs, or any other sort, and heavy metals in the form of lead, mercury, cadmium, etc. And undesirable chemicals could be any chemical which has adverse impacts, right? So, all of the above is the correct answer. Next is which of the what is the health impact of excess fluorine content in drinking water? So, can you mute yourself whenever you want to give the answer? You can unmute and tell. So, yes, can you mute? Yeah. So here, okay, I guess you have seen the answer. So let me tell you that fluorine is an important nutrient which is required by human body for dental growth or dental health and bone health. So for teeth, it avoids or it restricts the bacteria to grow, which causes plaque. Okay, and it also promotes newborn formation. But if there is fluorine which is above a permissible limit, because in India there are places you would have seen in the lecture that in the places like Gujarat, in the places like there are many other states where fluorine content exceeds above the permissible limit of 1.5 ppm. So if you consume such more water, then there are chances that your teeth may seem like this, which is because of the fluorosis that causes white and brown some speckles formation on your teeth, which is because of the fluorapatites which are formed. Okay, so excessive fluorine, it can cause damage to your teeth above 1.5 ppm. So that is nothing but fluorosis. Okay, it is the correct answer. Next is find out the most suitable option for the from the following representing the dissolved oxygen content in the natural water at normal pH. Can you tell me? Now you can unmute and tell me. So, what is the dissolved oxygen content and how it is used, and what should be the ideal concentration which is required? So, yeah, please, should I speak out the name or
8 to 9.
yeah?
Yes.
So, why 8 to 9 is required and like what is the reason behind it? Do you know? Okay, so reason behind it is there are living organisms in the form of plants which grow inside the water bodies. There are fishes, there are other aquatic animals which require oxygen for their survival, right? Because they also consume oxygen and they survive. So for those, the ideal concentration is 8 to 9 ppm, which needs to be maintained. Now, if water gets polluted, then this dissolved oxygen gets also altered, and that is how even living organisms inside water bodies they get affected by that change in the dissolved oxygen. They die actually. So that is the ideal concentration that's need to be maintained. Similarly, for human beings, 21%, as we know, is the oxygen which is present in atmosphere, and that is required. Okay, so if we go into the places where the altitude is much higher, the oxygen density due to low pressure will be lesser, and that is why we face issues with while breathing. Okay, we are not able to breathe properly. So certain concentration of oxygen is very important for our survival, right? Next is which of the following does not contribute to the pollution in aquatic bodies?
It's ozone.
Yeah, ozone is the correct answer because heavy metals, the plastics, because they are non-biodegradable, even pesticides, they are non-biodegradable, so they cause harm. Okay, ozone is a naturally occurring uh, uh, component, so it has lower, no toxicity, or it does not cause pollution. Next is which of the following fuels cause minimum environmental pollution?
Hydrogen.
Yeah, hydrogen is the correct answer. Can you tell me the reason behind it? Yeah, you told me the correct answer.
Ma'am, it is an exhaustible resource, ma'am. Sorry, ma'am, I don't know the real definition.
Okay, no issues. I will tell you. So, do you know, like, you are clear with the point that carbon dioxide above a certain limit is it causes global warming and it causes pollution, right? You know that fact. Yes, can
Yes.
you tell?
Yes, ma'am.
Yeah.
Yes, ma'am.
So here, if you classify the fuels, then diesel, petrol, and coal, they are carbon-based fuels, right? So carbon-based fuels, if you have combustion, then carbon it will combine with oxygen. So combustion is nothing but carbon. It gets converted to carbon dioxide by combining with oxygen. Okay. So here, what is the end product? It is carbon dioxide, which gets emitted into atmosphere. While in the case of hydrogen, the product that is formed is nothing but water vapor. Okay, so vapors are of water, they are obviously not harmful as compared to carbon dioxide in case of other fuels which is produced. So that is why you can say hydrogen is causing minimal environmental pollution. Okay, is it clear?
Yes.
Yes,
Okay.
ma'am.
Next is which of the following is a waterborne disease? Can you tell me?
All of the above.
Yeah, so that is the correct answer, and here are the reasons. So, typhoid, you can say it causes fever by if you get infection by this bacteria, and that is present in food and water, which if you consume, it causes fever due to typhoid, which is typhoid. Now, cholera is caused by this bacteria, and that is where this bacteria they consume uh, uh, like if you consume unsafe water, and that is where the microorganisms and bacteria, if it gets contaminated with human feces, then such bacteria, then it can cause cholera. Okay, and diarrhea, obviously, contaminated water, if you drink, it can cause diarrhea. So all of the above is the correct answer. Next is which of the following is not a greenhouse gas found naturally in the atmosphere? So here I expect you to tell me not only the answer but tell me the definition of greenhouse gas also. So can you tell me?
My answer is ozone, ma'am.
No. Answer I would say it is nitrogen oxide. Now can you tell me what is the role of a greenhouse gas?
Causes global warming.
Yeah, so but why?
Why? Ma'am, the temperature increase, ma'am. It won't. Observe the temperature and it will reflect again to the earth.
Okay, so let me just tell you. I guess you are not able to explain. I guess what like so. Let me say this is the Earth and this is the atmosphere around it. Now, when there are sun radiations coming to the atmosphere. There are various gases which has the tendency to absorb some of the radiations, and that is why we feel the warmth. Okay, so that is the natural temperature because there is a natural concentration of carbon dioxide, methane, oxygen, ozone, everything. Okay, so that is the ozone layer. Now, the naturally occurring gases, they has the tendency to absorb the uh, light and uh, have a certain warmth on the Earth atmosphere. Now, if you increase these concentrations of carbon dioxide, so more and more trapping of energy or more and more trapping of the light source which is coming to the Earth, it will happen. Okay, so more the carbon dioxide, more will be the absorbing uh, component or more absorption of light occurs and more temperature rises. So these gases which absorbs light, they are nothing but greenhouse gases. So carbon dioxide, methane and ozone, they have the tendency to absorb light, and so the one which does not absorb, it is nitrogen oxide. And these gases which absorb, they are known as greenhouse gases. And further, the rise in of the concentration of these gases have caused uh, the average temperature of the earth to rise, and that is nothing but known as global warming. So obviously you mentioned correctly that greenhouse gases, they are responsible for the earth temperature to rise, right? So now next is, which of the following particles is called particulate pollutants? So can you define what are particulate pollutants and tell me what is the particulate pollutant out of the options available? Yes, anyone? Okay, so here particulate matter or particulate pollutants are nothing but solid particles, okay, which are present in air. Okay, so these solid particles are very fine particles. So here the example is fly ash. Okay, so fly ash is nothing but some sort of ash particles which are very fine and present in air. Okay, so otherwise ozone, radon, they are all gaseous products, gaseous pollutants, you can say. So they are not particulate. Okay, so here fly ash is the correct answer. Next is main cause of temporary hardness. So, out of which of the following salts temporary hardness is observed? Can you tell me?
Ma'am, is that magnesium carbonate?
Yeah, you are correct. So, can you define what is temporary hardness and what is permanent hardness? Because here it is asked about temporary hardness. So, there are two types of hardness, right? Temporary and permanent. So, can you define or differentiate between the two?
Ma'am, temporary hardness is due to carbonates and bicarbonates, and permanent hardness is due to fluorides and sulfates.
Yes, so you are not like you mentioned correctly. So carbonates and bicarbonates, if they cause hardness, so that is temporary because they are easily removed by boiling the water. But permanents are because of sulfates and chlorides of calcium and magnesium, because you need some special treatment to convert those into some other or to remove the hardness basically. So you mentioned correctly, which is magnesium carbonate. Next question is find out the most suitable option for pH of rainwater.
It's 5 to 6.
Yeah, so 5 to 6 is the correct answer. And the reason behind this I mentioned in this class only, which is the acidic gases, for example, carbon dioxide, NOx, SOx, which causes slight reduction in the um, pH of water because there are slight formation of acidic components in the rain, and that is why slight reduction in pH is observed, right? Now, next is related to what we were taught in the last week. So, match the following. You read the left hand side and right hand side and match. Yes, anyone?
Yes, ma'am. Species is a group of similar organisms that can breed and produce fertile offsprings. Community is collection of organisms that live in a place with the sorry, ma'am. Community is an assemblage of different populations that live together, and
Yeah.
ecosystem is collection of organisms that live in place with the non-living environment. So the option
Yes.
is two.
Yeah, correct. So species are a similar type of organisms. Okay, for example, human beings. So human beings is a species, right? Community is if you are living in a house and some other organisms or collection of organisms they are living along with you. So that is a community. An entire ecosystem. Sorry, community is three different populations, and ecosystem is everything around you. Sorry, non-living here, that is ecosystem. So this P2, Q3, R1 is the correct answer. Next is what is the tropic levels PQR in the energy pyramids from the bottom to top. So recall the uh, food chain and what are the levels, right? I expect some another student to answer because I guess I don't know the name, but she is only answering right now. Maybe someone else or can answer. Yes, Manas, or anyone knows. We have discussed this in the class.
Ma'am, can I say?
Yeah, sure.
Ma'am, first is primary producers and P is
Along with that, can you give the example so that everyone, if they are listening, they will be able to again recall what are the examples of such uh, levels?
okay.
Yeah,
Yes,
if
ma'am.
you know, you.
Yes, ma'am. First is primary producers, which are plants.
Yeah, correct.
Second is primary consumers, which are herbivores like elephant, etc., which eat only plants.
Yeah, correct.
And secondary consumers are which depend on the primary consumers.
Yeah, so the ones who consume primary, they are secondary consumers. So you mentioned very correctly. Thank you.
Yes,
The
ma'am.
answer is producer, primary consumers, and secondary consumer. Yeah, so this is the diagram where producers are plant, then the ones which are consuming the producers, they are primary consumer, and so on. Which of the following is the correct correlation for exposure and risk assessment? Yes, anyone? Okay, so let me tell you, exposure is the nothing but a factor which defines how much more the exposure, more will be the risk factor.
Ma'am, first, ma'am, first one
So,
is that exposure equal to intensity and into frequency by duration.
no, no, no. Duration, it cannot be into denominator. Why? Because more the duration or more the contact time you are um coming with the coming in contact with the uh, pollution, more are the chances of risk, right? So more the time, so duration it relates with the time for which you are exposed to pollution, right? So in
Okay, ma'am.
case more the duration, more will be the exposure and more are the chances of risk. So it is direct proportional. So duration has to be in numerator. So correct answer is C. Okay, so more the intensity, more will be the exposure. More the frequency, more will be the exposure. And likewise.
Oh, okay, ma'am. Okay, ma'am. Thank you,
Okay,
ma'am.
thank you. So now next is a numerical where you the question is if a compound X has octane water partitioning coefficient as 110. So now the concentration in a lake water is given as 0.5 milligram per liter. Find out the approximate concentration of X in animal at the bottom of all the food chains. Right. So here I have mentioned what formulas you might use. So let someone please let define the terminologies with or help me define the terminologies which are mentioned in the question and we can solve later by using these two formulas. So the hint from the formulas you can take and later we can solve. Yes, anyone? Could you uh, identify or should I tell you? Okay, so should I tell you? Please someone respond.
Yes, ma'am. Yes, ma'am.
Yeah. So there are two terms given to you. Okay, so first is octane water partitioning coefficient, which is 110. So out of the formulas which are mentioned, can you just tell me which is partitioning coefficient or symbol for that? Okay, so let me tell you. So partitioning coefficient symbol is nothing but KOW, which is given to you as 110. Next is concentration in lake. It is given to you as 0.5 milligram per liter. Now here you need to find out concentration in organism, okay, in animal at the end of food chain. So out of these two, how will you find out this term? Okay. So for that you need to use these two formulas. So first is you know this, right? But you do not know bio concentration factor, from where you can relate the concentration in environment, which is lake here, and the concentration in organism, which is the animal at the any animal at the bottom. Okay. So first task is step one: find out BCF from KOW. Can you do that? So put up the values. Log BCF equals to 0.79 into log of KOW. Now KOW is already given to you in question, which is 110 minus zero point 0.4. So this is one entire term. So can you do a simple solution? Are you following with me?
Yes, ma'am.
So can you
Yes, ma'am.
do the solution of this equation? So what is log BCF coming to you? Can you calculate? Has someone got the answer? What is log 110 coming? Can you tell? Is it 2.04? Everyone following me? Here log is to the base 10. So log 10 of 100 and log to the base 10 of 110. It should come out to you as 2.04. Okay. Can you tell me, are you getting this answer or not? Anyone? Can you tell me?
Ma'am, 3.294.
Uh, which term are you telling? The final answer.
No, ma'am, sir. I'm just trying.
Do you have a scientific calculator, anyone, or you can even use your mobile phones? Nowadays, you can directly calculate logarithm and everything from your mobile phone, so you can use that. First, calculate log to the base 10 of 110. Are you getting 2.04? In your mobile phone, just press log and write 110. Are you getting that?
Yes, ma'am. 2.014. 041.
Yeah, so log to the base 10, 110 is 2.04. Everyone is getting like her, 2.04 is correct. Okay, so next step is solve this. So this should come to you as so first multiply 0.792 into 2.04. So that is 1.61. Okay, and minus zero point 0.4. So that will be,
1.21.
yeah, so that is nothing but 1.21. Very good. Now, how will you find BCF? This is the value for log BCF. Do you know how to find out BCF from this? Yes. So let me just tell you. Now, when you have log to the base, let's say here 10. So let me give you example of 10 of BCF equals to some value, let's say x. This is known. Okay. So to find out this value, to remove log, you need to have NT log. Okay. So for NT log of log, it will be here 10 to the power. So base to the power answer. Okay, so base here is 10 to the power answer. So NT log, when you take off log, it will be nothing but BCF. And NT log is nothing but base to the power of answer. So here it is 10 to the power x. Now to find out BCF, it is 10 to the power 1.21. Can you do this? Are you following me?
Yes, ma'am. Yes, ma'am.
Yeah, so please calculate 10 to the power 1.21. Is it coming to you as 16.18 or I guess 2?
Yes, ma'am.
Yeah, 16.2 everyone or 18? Yeah, and the unit for this is liter per kg. So next step would be, once you know BCF, so from BCF the formula is you can directly find out the concentration of in the organism because you are given the concentration in environment. So let's use that. Let me take a new slide. Okay, so here BCF equals to concentration in animal by concentration in lake water. Okay, because animal is consuming lake water. So to find out this, C animal is BCF into C lake. Okay, so put up the values. It is 16.2 into um, zero point 0.5, I guess. So do this. It comes around 8.1 milligrams per kg. Are you getting this? Can you tell me quickly?
Yes, ma'am.
Yeah, so should I move to next question, everyone?
Yes, ma'am.
Okay. The balanced chemical reaction for photosynthesis is given as dash. So let me first write what is a photosynthesis reaction and we can balance it. So here photosynthesis, for that CO2 it combines with water to form energy plus energy to form energy is from the sunlight, right? Uh, it forms sucrose and oxygen, right? Oxygen is emitted back into the atmosphere. So here you see carbon is having 6 atoms. So you put up 6 here. And again, the hydrogen, it is 12 atoms. So hydrogen will be, here it is 2. So 6 into 2, 12 atoms of hydrogen. So carbon and hydrogen, they are balanced. Now, oxygen and sucrose is already 6 present. So here 6 are there. And the total oxygen here, it is 6 cross 2, which is 12 plus 6. right? So 6 are already there, and 12 more needs to be present, or 12 no, more needs to be emitted in this side so that the reaction balances. So for that, since it is 2, so 6 into 2, it will be 12 atoms. I guess it is balanced now. Okay, so option A, right, is the correct balanced equation for photosynthesis. Everyone followed me?
Yes, ma'am. Yes, ma'am.
Yeah, thank you. So next question is, which of the following is not a renewable energy source? So um, tidal energy, wave energy, coal, hydro energy.
Coal based energy, ma'am.
Yeah, coal is the correct answer because renewable coal might get depleted because it is present in a very limited amount, while geothermal energy is the energy which is because of the heat present in earth. Okay, so that will always be there. Now, hydro energy is from water or uh, from any like turbine if you are using any natural source, for example, waterfall. Okay, so it is naturally falling and it will be falling every time. So if you are using that energy, then that could be hydro energy. Then there could be energy which is stored in waves of ocean. So that is nothing but tidal or wave energy. So that are always present. So coal, there are chances of getting depleted. So coal is not a renewable. Otherwise, you can have all other are renewable, right? Next is, which of the following has lowest power requirement for same equivalent brightness?
LED, ma'am.
Yeah, LED is the correct answer. Next question is, which of the following phase in treatment of municipal wastewater deals with the removal of coarse materials to avoid operational problems? Okay, so let me just tell you, I guess it was not there. So pre-treatment is given for coarse materials, for example, bigger materials in the form of plastics. Um, let's say you want to treat municipal wastewater, which might have some plastic bottles, which can have some fruit seeds. So such coarse materials, they can choke further processes, or they can be harmful to the instrument material itself because they can stuck or they can damage. So first and foremost thing is to remove them. So which is provided in the pre-treatment step where bar screens, or you can say chunni type of thing, which is having smaller diameter as compared to the coarse material. Okay, so it will obstruct to flow further in the water, right? So correct answer is pre-treatment. Next is, the steps involved in risk analysis are dash find the most suitable option. So which all are included? I guess all of the above we have discussed in detail, right? Yes. Last question. The process of evaluating risk resulting from hazard is known as dash.
Risk assessment.
Yeah, that is the correct answer. You are analyzing what is the risk and how it can impact. So that is nothing but assessment. So that's it. Like these are the questions. Now, if you want, we can discuss the tutorial questions which were discussed during the week. Maybe we have 10 to 15, 20 minutes more we can take, 15 minutes or so. So if you want, we can discuss the tutorial. depending on what you say.
Yes, ma'am.
Okay, so let's discuss that. So first question is compound X. Are you able to follow in the way I'm speaking, or I guess you are getting me, right? So after that we can continue. Okay, so here the question given to you is compound X has ether to water partition coefficient. So the partition coefficient given to you is K. Sorry, K that is given to you is 4. Okay, and now the total mass of X which is present or dissolved initially in water or 100 ml of water is 11 grams, right? So the concentration initially, C initial, in water is nothing but 11 by 100, right? Now, in first question is how many grams of compound X will be in the organic layer after one extraction with 100 ml of ether? Okay, so K is what? Uh, K is concentration in ether by concentration in water after the exchange has happened. Okay, so here the concentration that is there, it is initial. Okay, so after exchange whatever is remaining we do not know. So for that how we can do, let's say K is given to you is 4. Now there are two different layers, this is water and this is ether. So there is exchange of this component and initially it was 100. Okay, so total we know that summation of whatever is present in water and whatever is present in ether, it will give you to 11, right? So let's say concentration you can define is, let's say here it is present as X. Let's say here, sorry, in the question it is mentioned like this. So let's say here after transfer X is the amount which is present in ether phase. So what will be the amount which will be present in water? Can you tell me? Because the total remains always equal 11 because mass never gets generated nor it gets consumed, right? So total will be constant every time. So whatever is present in ether, that is X, plus whatever is present in water, okay, water phase, that is always equals to 11. So what remains in water is 11 minus X. Now to find out the concentrations, you have X in ether phase and the volume of ether phase is how much? 100 ml, right? So X by 100 is the concentration divided by whatever is present in water, which is 11 minus X, divided by volume of water, which is 100, is the remaining concentration, equals to 4. Now you need to solve this. So 100 will get cancelled out. X equals to 4 into 11 minus 4x. Okay. So here you will have 5x equals to 44 and x will be 44 by 5. You can divide this and get the answer of what is present in the ether phase after extraction, right? So answer will come out to you as 8.8 gram. It gets transferred to the ether phase and whatever remains is 11 minus x that will be remaining in water. Okay. So next question is, instead of single extraction, you have two sequential extractions. So first you have 50 ml of ether. You extract certain amount. Okay, so step 1 is 100 ml water and next is 50 ml ether. So again you have this, okay, 100 ml. Whatever is remaining, so again transfer or extract it with fresh ether 50 ml. Okay. and you see what is the total extraction done with this total 100 ml. Okay, so for that, how will you do? Let's say for first system we can write partition coefficient is 4. So similarly, let's say X is the amount extracted with 50 ml. So concentration X by 50 divided by 11 minus X by 100 equals to 4. Now here 50 by 100 will be 2. Okay. So 2X equals to 11 minus X into 4. So 2X equals to 44 minus 4X. So here it will be 6X equals to 44. So X will come out to be this. Okay. So again, similar step you have to follow for this. But what will be the total remaining? It will be this much. Okay. So this much is only present after first extraction here initially. So the sum should be, instead of 11, it should be X plus water equals to 3.67. Otherwise, the procedure is similar. Okay. I guess it is clear. Do you understand this question? Yes, anyone? Or is there any confusion at any point? You can tell me. Is it clear, everyone?
Yes, ma'am.
Okay. So let's move to next question. I guess we will discuss briefly because we have less time left. If a compound X has this partitioning coefficient 130 and concentration in lake water is 0.5, find the approximate concentration at the of in the animal at the bottom of all the food chains. So I guess this question is similar to what we have discussed in detail, like in the assignment question. I guess it you can do this question, just the value is different. Instead of 110 is the partition 110, you here you have 130 as the partition coefficient. Rest everything is same, right? So I assume that you followed that question, and so I will skip this. Consider consider a solution. Yes, someone was trying to tell anything. Consider a solution of ammonium sulfate. So write the formula of ammonium sulfate first. That is NH4 twice SO4, right? Prepared by dissolving 66 gram of anhydrous compound. Now here anhydrous means it is not having um, water molecules or hydration. Okay, so it is just this. Otherwise, if it has hydration, then there could be some X molecules of water, which is not present. Okay. Now it is diluted to 1 liter. And what is the concentration? So first, you need to find out in gram per liter. So gram per liter is nothing but gram of salt divided by solution volume in liter, right? This has to be in grams. So everything is in similar units is given. So it is 66 gram in 1 liter. So it is 66 gram per liter, right? It is very simple. Now next question is moles per liter. Okay, so for that you need to find out the molecular weight. NH4 twice SO4 is the formula. Now calculate the molecular weight. So for that, nitrogen has 2 atoms. So 2 into the molecular weight or the atomic weight of nitrogen, which is 14. plus for hydrogen it is 1. So total number of atoms here are 8. So 8 into 1 plus sulfur has atomic weight of 32 plus 4 into 16, which is the atomic weight of oxygen. So the molecular weight should come out to be 132 gram per mole. Now, if you want to find out concentration in mole per liter, so let's first find out what is the number of moles. Okay, so moles per liter will be moles of salt per volume. So here number of moles will be 66. Okay, that is the gram per unit molecular weight, which is 132, divided by volume, which is 1 liter. So it should come out to be, if you divide this, 0.5 moles per liter, right?
Yes, ma'am.
Okay, so next is you need to find out an equivalence per liter. Okay, so moles per liter is nothing but molarity. Now for equivalence per liter, you need to know what is the equivalence per mole of that compound. So here the maximum valency is 2. Okay, so the equivalence will be 2 equivalents per mole. So to find out equivalence per liter or normality, both are same. That will be nothing but molarity or moles per liter into the number of equivalents. So that is nothing but 0.5 into 2. You will get 1 normal or 1 equivalent per liter. Okay. Now next is gram per liter as sulfate. So you need to calculate what is the amount of sulfate which is present. Okay, so let's say 132 gram of salt has sulfate has this much, 96 gram of weight. Okay, so 96 gram of sulfate. Okay, so 1 mole of salt has 132 gram salt and 96 gram of sulfate. So out of 66 gram of salt which is taken, what is the sulfate weight? So cross multiply this. So weight of sulfate is nothing but 66 into 96 by 132. Can you do that? Are you following me? So it should come out to you as 48 grams of sulfate is present, right? And if you want to find out gram per liter, so that is 48 grams of sulfate which is present in 1 liter. So it is 48 gram per liter. Similarly, next question is for nitrogen. Okay, so 132 gram has 2 into 14 uh, grams of nitrogen. So for 66 grams, how much uh, will be the weight? So if you do that, it will be 66 into 2 into 14 divided by 132, which is 14 grams of nitrogen will be present in 66 grams of salt. So 14 grams nitrogen per liter solution. Are you able to follow this?
Yes, ma'am.
Okay, so let's move forward. Yeah, so octanol water partition coefficient of a pesticide is given to you. Calculate the concentration factor of it in fish to water. if the concentration of pesticide in water is given to you as 2 ppb. So similar question that we have done. First, you need to find out the bioconcentration factor by using this formula log BCF equals to 0.79. You just have to put up the formula partition coefficient here. By that you will get BCF, and concentration in fish will be nothing but P fish equals to BCF into C in water. Right? Similar to what we have done. Next question is how much solid waste is generated in tons per day from Roorkee and Meerut if their population is 1 lakh and 15 lakhs. So depending on the size of a town, the solid waste generated, it has a formula. Okay, so for small town which has very small population, the formula is this. Okay, so it is gram per day. Now, which is nothing but population into 100 or 200 maybe. So it is from this to this grams per day, right? So population here given to you is 1 lakh. So put up that into 100 divided by, now this is in gram and we need in tons. Okay. So tons for that gram, 1 gram is 1 by 1000 kg. Okay. And 1 kg is 1 by 1000 ton. So here if you convert 1 gram into a ton, so it will be 1 gram is equals to 10 to the power minus 6 tons, right? So if you put up all the values, it will be 10 tons per day or 20 tons per day. So this is the lower limit and this is the upper limit. So we have the limit, okay. Within this range, the solid waste might be generated. In the other case, it is a medium town. So depending on the population, it is comes under the category of medium town. And so for that, the solid waste generated should be population into lower side, it will be 300. Higher side, it will be 400. Again, it is gram per day. Now again, if you put up the conversion factor, it will be 10 to the power minus 6. And if you solve it, it should be 450 tons per day to 600 tons per day. Next question is when chlorine is used for disinfection of drinking water, chloroform is generated by reaction of chlorine with residual organics in water. So Cl2 gets converted to chloroform, and you know chloroform is it is given to you as anesthesia, so that you can say it is a harmful reagent, right? So estimate the ingestion intake rate for non-carcinogenic effects on an adult resident in a home receiving tap water with an average chloroform concentration this, and what is the risk? Oral RFT of chloroform is this. So I is having this formula. Now here we are targeting an adult. Okay, so for adult, the concentration is given to you is I guess they have written the concentration wrongly. So this is nothing but the concentration. You can use 75 or 65 microgram per liter, but this concentration in this formula has to be in milligram per liter, right? So whatever you use this concentration. Now to convert in microgram per liter, 1 milligram is, or sorry, 1 microgram is 10 to the power minus 3 milligrams. Okay. So if you convert this microgram into milligram, it has to be divided by 1000, and that is why it is 0.065 or maybe 75. You take this concentration, right? Now next is intake rate. Okay, so you are consuming water, so it is on an average an adult consumes 2 liters in a day. Okay, so 2 liters per day is taken because that is a standard value. Now, exposure frequency, how much you will be exposed? It will be 350 days on an average per year, and for an average time of 30 years where you are living. Okay, so that is there. And here the weight of average adult is taken as 70 kg, and this is the amount of time which will be exposed. So 365 days in a year for 30 years. Okay. So if you calculate, you will get this value. Now you need to find out the risk, which is calculated by hazard quotient, which is nothing but RI into RFD, because it is a non-carcinogen. Now in case of carcinogen, HQ will be I into SF. Okay. So if you do calculation, RFD is already given to you. So okay, sorry, it is divided by RFD divided by SF. I divided by RFD. So if you do that, if HQ is less than 1, then we can say that it has acceptable risk factor. Otherwise, it is causing risk to whoever is consuming. So here it will be coming as less than 1 because it will be 0.18. Okay, so need to be power minus 2, 10 to the power minus 3. So if you do this multiplication, it will be 0.18, right? So it is not hazardous. Next is also a similar question, but here you are given it is a carcinogen. Okay. So for carcinogen, what you do, you have is this I into to find out I into SF as the factor. So I you find out in similar ways, and you multiply this with slope factor, which is already given for benzene, which is the pollutant here as carcinogen. So if you do this multiplication, I into SF, you will get the factor, and it has to be within or less than 10 to the power minus 6. But since it goes above the threshold limit, which is already given to you, there are chances that it can cause some adverse impact, right? So that's it for today. Do you have any thing more to discuss?
No,
Otherwise,
ma'am.
we will end this. Okay, so are you fine with the procedure that I followed today? Yeah, are you fine with the procedure? Please do let me know if you need any change in the procedure, that we might focus on this more or this more, like theory or numericals, what you need more focus.
No, it's okay. It's okay with me, ma'am.
Sorry, you are not audible actually.
It's okay with me.
Okay, you are okay.
Yes, ma'am.
So that's it for today. I hope everything was clear. If you don't have any further doubts, we can end this session today. We will meet in the next class on Tuesday next week, same time. Okay. I will stop this meeting. Yeah, thank you everyone for joining. Thank you everyone.
Thank you, ma'am.
Thank you everyone.
Thank you, ma'am.